AVL trees are a special type of binary search trees that automatically rebalance themselves every time we add or remove nodes. They do this by ensuring that the difference in the height of the left and right subtrees is never more than 1. If the difference is more than 1, they rebalance themselves using rotations. In this video, we're going to talk about the different types of rotations and how they work. This is super important. It comes up in exams and interviews. For example, they give you a series of numbers to add to an AVL tree. At each step, you should demonstrate that you understand where the tree is imbalanced and how to fix it by using a rotation. Most of the time, they ask you to draw this on a whiteboard because coding the solution can get a little bit complicated and time-consuming. So, we have 4 types of rotations: left rotation, right rotation, left-right rotation, which is a combination of the last 2, and right-left rotation. Which rotation we use depends on what side of the tree is heavy. Let's look at a few examples. Here we have a tree with these 2 nodes, 1 and 2. Now we add the 3. Our tree looks unbalanced. We can prove this by calculating the difference in heights. We always start with the node that we just added. This node doesn't have any children on the left or the right side, so on both sides, we have a height of 0. Now we go up the tree. On the right side of the 2, we have 1 edge, so here we have a height of 1, and on the left side, we have a height of 0. The difference is 1, so this node is balanced as well. For the 1, on the left side, we have a height of 0, and on the right side, we have a height of 2. The difference is 2, so our tree is imbalanced here. Now, because our tree is heavy on the right, we have to perform a left rotation to rebalance the tree. Imagine we put a weight on top of the 1. It gets heavy and drops. So it will become the left child of the 2. Now our tree is balanced. So as you can see, after a rotation, one side goes up, the other side comes down. In other words, the height of one side increases by 1, while the height of the other side decreases by 1. This is how our trees get balanced. Now let's look at the right rotation. Here we have a left skewed tree, so we need to rotate it to the right. But before we do so, let's find out at which node we have imbalance. Let's say we just added the 1, so we start here. On the left side, we have a height of 0. On the right side, we also have a height of 0. So we're good here. Let's move up. For the 2, on the left side, we have a height of 1, and on the right side, we have a height of 0. We're still good. For the 3, on the left side, we have a height of 2, and on the right side, we have a height of 0. The difference is greater than 1, so this is where we have imbalance. We need to rotate this node to the right. So we put a heavy weight on top of it, it drops, and becomes the right child of the 2. Now our tree is balanced. Now let's look at double rotations. There are times that we cannot rebalance a tree using a left or a right rotation. We need to combine these rotations. Here's an example. Let's say we just added the 7 in this tree. We start by calculating the height on the left and right side of this node. Here we have a height of 0 on both sides, so our tree is balanced here. What about the 5? On the left, we have a height of 0, and on the right, we have a height of 1. We're still good. What about the 10? On the left, we have a height of 2, and on the right, we have a height of 0. So we have a problem here. Now, the imbalance is in the left child, right subtree. So we need to perform a left rotation followed by a right rotation. Once again, we have imbalance in the left child, right subtree. So left-right rotation. Let's see how it works. First, we perform a left rotation on the 5. What should happen? The 5 should go down and the 7 should go up, right? It's like putting a weight on top of the 5. It gets heavy and moves down. At the same time, 7 goes up. Now we have a left heavy tree. How do we rebalance this? By using a right rotation. So we rotate the 10 to the right, and now our tree is balanced again. Now, don't worry if this concept looks a bit strange. We're going to have plenty of examples, and you're going to master this. It's actually very easy. It's easier than coding. Now let's look at the right-left rotation. Here we have the opposite of the previous example. We just added the 7, and our tree became unbalanced. We calculate the heights, and it's obvious that the 5 is violating our balance rule. Where is the imbalance? In the right child, left subtree. So we perform a right-left rotation. First, we rotate 10 to the right. It will come down. Now we have a right heavy tree. So we rotate the 5 to the left. And now our tree is balanced again. So this is how rotations work.